going to do a couple of problems together, and then you guys will work on your own for a little bit before we take this quiz towards the end of the period, okay? So, these problems, these heat phase change problems, I like to draw the graph first. You don't have to do this, but I like to, and here's an easy way to do it for you. Here's what I do. I draw my axes, up, flat, up, flat, up. The first flat part, where there's a phase change, is at what temperature?
0.
The second one is, there you go. So you guys can feel free to use that strategy. You don't have to draw that, but you are encouraged to. Seems to help folks. I'm going to go ahead and use my nice printed one I have on there from beforehand, but that's how you can recreate your own if you don't have it printed on your quiz, which you won't. All right. Now, before I even touch any of the numbers, I'm going to find out how many Q's I even need to calculate. Keep things nice and organized. So, I got a 75-gram ice cube. It's at negative 85 degrees Celsius. Negative 85, remember these are our temperatures here, 0 for that first bridge and 100 for that second. I don't know exactly where negative 85 would be, but it would be somewhere down here, okay? And again, I don't really care about the graph that much. I just want to make sure I'm in the right section. Where would 185 be on this graph? The very top, somewhere up here. So I just want to know where I'm starting and where I'm finishing because that'll help me count how many Q's I need to calculate. So I'm just going to count every section. 1 Q, 2 Q's, 3 Q's, 4 Q's, 5 Q's. Okay, looks like I need 5 Q's here, which is the maximum. So before I do any numbers, I'm just going to go ahead and slap 5 Q's right there onto my paper. So I'm staying super organized. That way you're going to find it harder to make a mistake. And if you were to make a mistake, Mr. Pilcher can see that just a tiny little one every now and then if you show him all his work, and he can just take off 1 point instead of all the points. All right. Now this first section, okay, this first section here I have highlighted. Is there a temperature change for Q1? Yes, there is, so I'll be using Q equals MC delta T, because there is a delta T, there's a change in temperature. My M is going to be 75 grams. All of these are going to start out that way, because the mass will be the same throughout. Now, what is my C for this section? 2.06? Why not 4.18? 1 second there, here.
I already got the question.
Because it's a solid, right? It's 2.06 because it's a solid. We're looking at this number right here because we're dealing with solid H2O because it's below 0 degrees. Yes, there, Sarah?
Will the mass ever change?
No. So all of these are going to start with 75, yeah. And my change in temperature for just this section I have highlighted would be what? Be 85, because you're going from negative 85 up to 0. So that's why your delta T is 85. All right. Now my Q2, that would be here. I'm going to use a slightly different highlighter color. Go with green. Is there a delta T? Is there a change in temperature right here? No, there's not. So I can't use Q equals MC delta T. I'm just going to use Q equals M delta H. Is this the cheap bridge or the expensive bridge? It's the cheap bridge. We're talking about this guy right here, the 334. It's 334 joules for every single gram you want to carry across that bridge. So if I have 75 grams, I got to pay 334 joules for each one. Okay. Now, back in the yellow highlighter color, here's my Q3. Is there a delta T for Q3? Is the temperature changing? Yes, it is. So I use Q equals MC delta T. My M would be 75. What is my C? Wait, but it's just 2.06. You can't change it like that. Oh, because not because it's turning into a liquid, but because it is a liquid this entire section. We turn it into a liquid down here in green. That's where we melted it. Okay, we took it from ice to liquid. But this whole time it's liquid on this line right here that I have highlighted in yellow in the middle. So it is 4.18. How much is the temperature changing for this Q3, this third section? 100. It's going from 0 to 100 in this particular section, so my delta T is 100. All right, my Q4, back in the green highlighter color. Is there a delta T for Q4? Nope, so I will not be using Q equals MC delta T. I'll be using Q equals M delta H. My mass is 75. Is this a cheap or expensive bridge? Expensive, so now we're using, now we're using this higher price of 2260. And that's it. That's all I gotta do. Just gotta pay the bridge price. And lastly, back to the yellow highlighter. This fifth section right here, is there a delta T? Yes, there is. So I use Q equals MC delta T. My M is 75. My C is 2.02. Now it's this guy, because we're talking about a gas, because H2O above 100 degrees is a gas. And how much am I changing in temperature in this last section? 85, because I'm going from 100 to 185. All right, so I got everything written out so Mr. Pilcher can see every step along the way. That comes out to be 13,000, 25,000 or so, 31,000, 169,000, and a little over 12,000. What am I going to do with all 5 of those Q's? Add them up. So I'm going to get a grand total. Uh-oh. Come on, smartboard. Grand total of 251,910 joules. I'm going to slap that capital J on there. I'm going to box it up. Oh, Ryan was ahead of me. Box it up. Absolutely. Like the model student. Not bad, not bad. Now, this is the maximum. The most complicated they can be is 5 Qs. They will not always be a 5Q, because you may not always need to go through all the sections of the graph. Let's do one more together, and I'll let you guys do your own thing. Let's take a look at one more here. We're going to take a look at number 4. Number 4. Now you will notice that the heat is being released on this one. Now, in other words, we're cooling this puppy down. It will not affect our calculations in any way. No negative signs, nothing like that. But I just want you to know that, like, the way we communicate negative signs is we just say, like, oh, heat was released or removed or something like that. So we use our words to indicate the direction. We don't use that negative symbol, okay? So in terms of the math, nothing will change. So I just want to kind of point that out. All right, I'm going to draw my little 5Q graph real quick. Boing, boing. Up, down, up, down, up.
Oh, 4.
Yep, number 4. The lower bridge is at 0 degrees. The top bridge is at 100. All right, how many Qs do I need? Well, this is 454 grams of steam at 100 degrees Celsius. So it's on the 100 degrees Celsius line. I think that should be obvious because of that temperature. But are we starting here or are we starting here? Are we on the left or the right of that 100 degree line? I heard left and right. Which one is it? It's the left, right? Or is it the right, left? What? Okay. You should start right here on the right.
Yeah.
Why is that, Mr. P? Because this is steam. It's currently a gas. If it was 100 degrees liquid water, that would be starting right here. Okay? Because that's before the water has boiled. But over here, that's when the water has already boiled. It's already a gas. And since this is steam, that's a gas, we need to start on the right-hand side of that. And that's very important because if we start on the left-hand side, we would forget to calculate a whole entire Q. So we'd miss one of our Qs of this problem. Is there anyone who's confused about why we start on the right side of the 100-degree line instead of the left? Feeling pretty clear about that? Okay. All right. Now, it's going to 30 degree water at 30 degrees Celsius. Where would that be, generally speaking? In between the 0 and the 100, okay? And Mr. Pilcher's not going to grade. He doesn't really care where you put that. As long as it's in between the 0 and 100, we're good. All right, now, let's go ahead and count how many Qs we need. We would need 2 Qs for this problem because there's 2 different sections. So I'm going to go ahead, model student. I'm going to slap a couple of Qs on there. Make sure it's nice and organized. For this first Q, here in yellow, is there a delta T for that? No, there's not. We're crossing a bridge. Is it the cheap bridge or the expensive bridge? It's the expensive bridge, okay? And so it's going to be mass times your delta H, and since it's the expensive bridge, that's at 2260, a number you don't have to memorize. For my second Q, here in green, is there a delta T? Yes, there is. The temperature is changing. So I'm going to use Q equals MC delta T. My M remains 454 grams. What is my C for this Q? Yeah, Harry?
I got a question.
Oh, got a quick question? What's up?
What I can remember, how do we determine which one's the expensive and not expensive bridge?
Oh, the top one's the expensive one, that's all.
Yeah, but how do we know which one's like fusion and vaporization?
Oh, vaporization. Think about like you're vaporizing something, that would be that top one, and fusion kind of has to do with the idea of liquid going to solid, that kind of idea. But yeah, they call it the fusion bridge. That's that bottom one, and the vaporization one's the top one. But I think it was more the cheap and expensive bridge. Hey, what is the C for this middle section now? Which one is it? Which C do we use? Are we solid, liquid, or gas right here in the middle? We're liquid, so we need to use that 4.18. Does that make sense? Because it's liquid. If we were on one of the other sloped lines, we'd use a different value, but because we're in the liquid, 4.18. How much is the temperature changing in this particular section? 70, because we're going from 100 down to 30. You do not need to use the negative 70 symbol. Okay, ignore that negative. We just use our words to describe that. So I'm going to go ahead and plug those numbers in. That first one comes out to be equal to a little over 1 million. This one's like 130-something thousand. What do I do with those two numbers? I add them up. You got it. So 1,158,880.4 joules. Slap the J on there. And of course, box it up, baby. Boom. So this particular problem was only a couple of Qs. Okay, so 5 Qs is the maximum. You won't always have to use all 5 Qs, but you might. You may be releasing energy, you may be adding energy, but the calculations are still the same. So since this class period will be over at 10:24, we will be starting that quiz just after 10:05. So you'll have a little bit more than 15 minutes to work on it. And that's a wrap. So you folks at home, make sure you do the rest of this worksheet and get ready to play when you return for your quiz.